Good morning, everybody. Thank you for coming. My name is Adam Evans. I work in the Google Maps API, part of Google, part of the big Google Cloud team. This is the first of 8 sessions in the Maps track here at Google Cloud Next. We're going to focus today's session on talking about optimizing and making more efficient your business operations using Google's location APIs. I did want to point out we have quite a few other sessions as well, so if you have questions about applying maps in your application that don't get addressed by this session today, it's a big, rich, deep suite of APIs, so please be sure to attend some of the other sessions. Come and connect with some of the folks in the Maps team after this session. We'll love to make sure everybody goes home with their questions answered. We'll have some Q&A as well. So today, my colleague David and I are going to explain why Google believes that location is really critical to business operations. Talk a little bit about trends that we see in the use of maps and location in more B2B non-traditional use cases for maps beyond looking at just looking at visualizing a map. Just to get a sense of the audience here to make sure we can make this relevant to you, can I get a show of hands for those who identify more as a developer? And how about those who identify more on the business side of their business? How about both? Everybody's a hybrid these days. There we go. Okay, that's great. How many of those in the room are currently implementing location or maps tools of any kind in their applications today? All right, good. So there's some deep fluency here. How many have not but have some interest in using location in their tools? All right, again, that's great. So this is a pretty broad cross-section, which I think gives us an obligation to give a little bit of broad context as we get started here. The world is a really busy place, as we know. At Google Maps, we see a lot of businesses asking us questions every day about how to make better sense of their employees, their customers, their suppliers, the operations of their business as it moves around in the world. And this is an area where Google's deep understanding of the world and the places in it can be useful to you and to your businesses. Picture a major city that perhaps is trying to do urban planning, plan traffic management, plan the movement of people and goods, zoning, sprawl, expansion. They may have invested hundreds of millions of dollars in capital in perhaps expensive sensors to monitor the movement of vehicles over roads. This is the kind of place where Google's real-time traffic information, sourced from billions of connected devices and connected Google Maps phones with location opted in, can help drive better business decisions for that city. We want to be able to answer questions such as, where should we plan the next expressway? But we also want to help individual businesses, from the really large corporations down to the very small startup, to answer questions like, where should my salesperson plan a visit based on density of their customers? What is the most efficient route for them to visit 10 or 15 customers in a very short visit in a layover, for instance? If I'm a taxi company, how many vehicles should I dispatch just after midnight on New Year's Eve, based on historical traffic patterns? These are questions that Google can and wants to answer through our location APIs. In other words, we want to make it easier to bring the location of the real world, this high-resolution, deeply accurate, scalable map that Google stands up for our consumers. We want to make that available through APIs so that you can access those data and make decisions about your business. Location is something we just naturally use to connect us with our friends, with our colleagues, with each other, with our customers. If you think about this, think about what's on your phone right now. Think about the number of apps, hopefully in addition to Google Maps, the mobile app, that you use that already natively use location. A rideshare app like Via, who offers $5 flat rate rides in New York City, powered by Google Maps. Now, how can they do that at that cost? Because the infrastructure costs of building on Google's platforms, including our APIs, are so low and so efficient that they can plan an entire ride-sharing application around an easy-to-build mobile app and support from Google and our partners to put together a ride-sharing application. Think about a vacation rental application like Tripping, where they can provide deep context about a place you might want to visit. Context such as, are there hotels, how far are these hotels from the places of interest that I'd like to visit? Google has a point of interest database with hundreds of millions of points with the type of places that might interest you on a visit. Do you want to visit an amusement park? Is there a church nearby? Is there a place that I can stop so my daughter can go to the bathroom on the trip? And speaking of which, Google's Maps also help answer that. I have a 4-year-old girl, and I've had to answer that question, Daddy, how long until we get to Space Mountain at Disney World? So we can provide that immersive experience for location in Maps. If you've ordered a coffee recently through your Starbucks mobile app, you want to make sure that it's hot when you arrive. A lot of people order the coffee when they're standing in a long line. You can even order it in the car on the way in. How do we know that coffee is going to be hot when you arrive? We need to know exactly when that person's pulling into the parking lot so you can be sitting there steaming on the counter. Well, traffic can be pretty bad where I live, so if I order the coffee in the car, my app, Starbucks can tell how long it's going to be using Google's real-time traffic and the predictive travel time features, such that they only spin up the order so that the barista has prepared my cappuccino just in time so that it's still ready on the counter. The feature I really need is, hey Adam, you're one coffee short of a wakeful morning. You've overshot the place. Here's a little warning. And perhaps a geofence can tell me to turn around and go back and pick up the coffee. So I like to ask this question a lot. So far I've talked about consumer experiences and the experiences that we have as consumers using location in apps. But what does this mean for a business? I think from the show of hands, a lot of people here work in and operate businesses that don't necessarily have a citizen or a consumer interface as their primary means of connecting with the world. Maybe you want to connect with a supplier. Maybe you want to connect with your own employees. What does this trend towards using location to connect with people, what does it mean for your business? Anybody have any guesses? You can shout it out if you know of what this is. What we're showing here? These are the movements of phones. These are the movements of mobile phones with location opted in, tracked through Google Maps, and you can see the movements through time, throughout the day, the living, breathing city as people commute generally from the suburbs into downtown. This is possible to drive all those really complex decisions about planning that I talked about, whether it's for a city or for a taxi company or for a dispatch company. All of these decisions are driven by a massive amount of data. What's relevant here is that to get the position of something to within a few meters, this is a major, major change that's kind of happened quietly around us in the last decade. 15 years ago, the cost to get the position of something within a few meters was 2 or 3 orders of magnitude higher than it is right now. You used to need this differential GPS equipment. If you don't know what that is, it's like an antenna and backpack system that surveyors would use to understand where a point was on the ground pretty accurately. That's now subsidized by your mobile carrier and the location driven by every mobile phone. And that's really done a lot to connecting people with the places they need to be. But what we think is really relevant, and there's been a lot of talk about the Internet of Things and the impact that that might have on your business and the world in general, is that if devices become connected, billions of devices, not just phones that natively include geolocation, but perhaps a little tag for my dog who has a bad habit of running away, perhaps a fitness band that can track how far you've been running, maybe every single piece of manufacturing equipment such as expensive construction equipment used on a construction site that has a habit of, that are prone to theft. The tracking of everything is becoming cheap, an order of magnitude or 2 cheaper. And as we know just in general for trends that happen is that when something gets a lot cheaper, new business models become possible and old ones get under stress. So the reason that we want to talk about location and what it means for your business today, and we're going to show some examples, is that we think it's critical. Our customers are coming to us saying, I need to have a strategy to incorporate location in my business operations because everything is becoming connected and everything has a position. Increasingly, that position is not necessarily shown on a map. We believe at Google that we're entering the 4th phase or the 4th wave of mapping. Now, paper maps are something with hundreds, even thousands of years of history. Cartography's been around for a long time, since the first maps created by the ancient Greeks and Ptolemy, all the way through the paper maps that your parents probably printed out, those AAA triptychs that you'd have, that big stack of paper you'd have to take a trip with your family. Perhaps in You started using digital maps through geographic information systems if you work with them in business, or as a citizen, you might have started using them with the launch of Yahoo Maps or MapQuest, or when Google Maps launched about 12 years ago now. And then we moved into a more dynamic, real-time picture of the world, the third wave, and that's where most of us are today. We can get a real-time picture of where we are, such as those apps that I showed earlier on screen. Automotive GPS dashboards are now integrated to give you a real-time picture of where you and all the vehicles are around you in order to give you traffic. But we think we're entering into a wave where location can be more intelligent, and the actual map, which, let's be honest, we don't need to always glance down at our phone to understand the estimated time before I arrive at my destination. All I need is the ETA. Maybe I need it just as a voice prompt. Maybe my delivery driver just needs to know exactly how far ahead of schedule they are. The directions are being given to them through the dashboard equipment. So we think we're moving to a world where predictive analytics and machine learning are allowing devices, people, and vehicles to connect without the need to visualize that on a map all the time. And then ultimately, if billions of devices become connected, that we'll be able to extract some patterns of information and learn more about our business. And this is where we think it's really exciting. So the reason I've given you this preamble is to get to an interesting story here. I had the privilege of talking to the chief operating officer of a really interesting software company, small company, and they started trying to fill a niche in dispatch tools for small businesses. Now, big companies who operate huge fleets have long had access to dispatch software. That would mean telling an ambulance or a truck driver in a large fleet where to be at what time and when to pick up a load and drop it off. They'd have tools in the vehicle, and they'd have tools back for the dispatcher back at the head office. But small companies, like a florist, perhaps a small mom-and-pop shop delivery company, you might have 2 or 3 trucks, a couple of taxis to drop off the flowers before the wedding. They never had access to this. So the software company I was speaking with built a beautiful tool. It was a tablet that you could buy in a software as a service model every month. It came with a telematics device, which allowed, through the airwaves, to send a little bit of information back to that company and describe where the taxi was, or describe where that florist was, and have the same kind of robust tools. And we went to speak with them. They were using a competitor system to Google Maps at the time. And we said, would you like to transfer over to Google? And they said, yes, but to us, visualizing that data on a map, yeah, that's interesting. And Google Maps are great, and they provide me with satellite pictures that we really like and some place information. But Adam, what we really want to talk to you about is something that'll make a difference in our business. Because the challenge that this person had is they had 10,000 customers. You think about this cost of servicing. Any of you who own a business or operate the business, you know how much it costs to keep a customer happy, informed, and serviced. They had 10,000 customers, and they were a small company. Their customers only had half a dozen or maybe 10 vehicles each. That's 100,000 vehicles, 10,000 customers. Think about what that means for their margins. To grow, they had to service 10,001 customers, 10,002. They wanted to grow and break out, and they said, Adam, can Google help me? We worked with the Google Cloud Platform Analytics team to get creative. They said that they had the right to look at the movements of all of those 100,000 vehicles in their downstream customers' fleet. Every 2 minutes, they would ping one of those vehicles and get a little data packet back. It's about 100 kilobytes, and in there it was the speed of the vehicle, what it was carrying, flowers, for example. How fast was it going? Was it parked? Where was it parked? The latitude and longitude of that vehicle. And all of that position information came back to a server. And you think about what that means. 100,000 vehicles, roughly every 2 minutes. That's 72 million data points a day across the aggregate fleet. Now, they weren't allowed to identify their customers by name, but they took that aggregated information, and through some data science, they were able to draw statistically significant patterns of the movement of their customers to learn some great things. Here's one of the things they learned. They learned that a significant number of customers idled longer in front of a coffee shop than they did in front of a warehouse. That's interesting. They learned that 2-axle truck traffic in and out of the port of Vancouver was greater than 4-axle truck traffic. Now, I don't know what to do with that information, but there are organizations who really want to know that kind of thing. So think about this. A small software company who had a tough margin growth business for small mom and pop delivery shops, continued to run that business, and then analyzed their data using Google Cloud Platform and location. Keep in mind, the location is critical for all of this. To get the address, to get the place type from Google's Places API, to get all of the contextual information required to run that data science, you need the location. So they ran location analytics on the aggregated database and launched a new business. They're now a data science company, and they sell packages of information to a hedge fund, to an insurance company, and they've learned a lot about data science by working with Google and working with location. And the reason I love that story is twofold. One, small companies get access to incredible technology in a way that only big companies used to have access to before. But two, they did all of that in a short period of time. And with a relatively low cost base, they're leveraging the location data from their own existing business to learn new things. So we think this is exciting. So let's talk a little bit about some use cases here beyond that fleet company. How tracking in particular drives business decisions. We have a lot of companies that build asset tracking solutions for more than just tracking trucks. They might track the position of their employees, the efficiency of their sales force as they go to visit different customers in the world. They might be looking at optimizing the number of vehicles that they allocate to a problem, such as the taxis on New Year's Eve scenario that I gave. So let's look at a few of these here. In order to provide a great customer service experience, how many people in the room here have had that frustrating moment where your cable company needs to come and service your cable and says, please be home between the hours of 8 a.m. and next week? Right, we've all been there. So part of the challenge there that company really runs up against, we know because we've worked with some of these companies to improve that customer service experience. The challenge they have is a logistical one. They have one service person who has many service calls to attend. And then they have the customer, that's you. You may be at home hoping to have somebody come to visit you, but they have a delay from the previous job. Using location to connect the customers with the service people is a simple thing that can improve customer service and make a massive difference to your market share if you're in a service business, like installing cable, but perhaps even for delivering the mail. Customers can get a real-time status for the position of their package if it's being tracked in a vehicle, and even a notification of the estimated time before it's there, so that you can be at work and say, oh, delivery person's coming in the next 20 minutes. I'm just going to pop home quickly, pick up the package, sign for it. Companies like Fleetminder have been using our asset tracking platform, using our maps, using our real-time traffic and our places information to make their business more efficient for their downstream customers. And we have a great quote here from the CIO of Fleetminder that says, Google's mapping solution has helped them cut their own customers' inefficient driving in half and reduce incorrect deliveries by 20%. That is the kind of statement that you want to make to your customers, to say that we've reduced your inefficiency significantly, your fuel costs and your time. Another really interesting use case for this is the full utilization of all the equipment out there. If you've ever seen a construction site, you might notice that there's a lot of equipment there. Anything from a great big digger all the way down to a generator running some remote lights, or a scissor jack that allows people to work up on the second floor in a construction project. This equipment is typically rented through a series of businesses that maintain inventory. The equipment gets beaten up and needs service regularly, and it needs to be maintained in different inventories around the world. If you are running a large construction project and look to rent this equipment, you need to be sure that the inventory is there and available. And it's been a major challenge for businesses in this space to maintain availability. You can lose business if you don't have equipment that's ready and has been serviced. This was a challenge faced by one of our customers who implemented tracking devices using geolocation on all of their equipment. They were able to reduce theft. They were able to monitor the service intervals and the number of hours of service that each piece of equipment had gone through, so that they could be sure that when the equipment was being allocated to a new job, that it was ready for service. But the location component was critical. If you went to rent equipment in Dayton, Ohio, and it wasn't there, their database system in the back end needed to check the real-time location of other availabilities. So over in Cincinnati, there may have been the same kind of equipment available in another branch. That led to a massive increase in customer satisfaction for the business that implemented full scheduling and utilization by just tracking the position of their equipment. By having a real-time view of vehicles, dispatchers can track global orders and shipments and have a dashboard picture of the operations of their business. Now, many businesses are doing this today, and where Google's really been enhancing it has been providing contextual information. Is someone in front? Where are they? I have their latitude and longitude. What's the address? And using Google's geocoder, I can get the address. Using Google's Places API, I can now see what type of address is. Are they in front of that warehouse or in front of the coffee shop idling a little bit too long? I can get live weather and traffic by correlating that position to other feeds and really get an accurate picture of my business as it is now, including meeting dynamic customer needs such as rerouting orders. I want to tell another interesting story, working with a company that builds small device trackers for very sensitive goods. Can you imagine if you were trying to ship a drug sample, a package of drug samples, or if you were shipping an organ in the organ donor system? These are high-value goods. They're insured. They're insured by an insurance company who writes a policy based on the likelihood of that good to have to be replaced. And when you're insuring something like drug samples or a box of Rolex watches, you want to make sure you understand the risk to that shipment. This company that we worked with makes a tracker about this big, and it has some interesting things in it. Its tracker has a humidity sensor, which I guess is important if you're trying to understand the health of some drug samples. Humidity and temperature. It has a tip tilt sensor that knows whether the box was dropped. It has accelerometers to know whether it fell off a shelf and might be damaged. But the key thing was that before they came and worked with Google, the package would arrive, you would open it up and then find out the damage. You would remove the tracker, plug it in, and understand what happened. But it was all after the event, and it had a huge impact on the customer's rate that they paid for the insurance of the package because they could not trace where the event happened. The liability was not known. So the rates to insure untracked goods were really high. This company implemented through really low cost. Remember I was talking about that trend, the cost to find the position of something's now cheap? It used to be really expensive to know where something was. Now they put a small Wi-Fi, low battery power requirements, and really, really low cost to put a Wi-Fi connector in their device. And anytime that package moved through the world, it might occasionally see a Wi-Fi signal. On your phone right now, how many Wi-Fi hotspots do you think you can see, roughly? 10? 20? As these packages move throughout the world, they would see a Wi-Fi hotspot. Google offers a global geolocation API that has a georeference position for Wi-Fi hotspots. And that means that these devices' positions are known as they move through the world. So when the box was dropped, it can now be correlated to a position. If the box was tipped, we know exactly where that was. Geofences and real-time alerts could be sent up. And this had a material impact on the cost of the insured goods for everything that this company provides. They have a huge advantage in the market now over their competitors because they implemented location in their tracking. Vehicle telematics are an interesting and broad business. We could spend an entire session just on this alone. Companies such as Mojio and Dash have built platforms connected to Google that allow a better relationship between the driver and the vehicle and all sorts of other businesses, including an insurance company who might want to offer you a discount on your driving if you're a safe driver and you don't accelerate hard or brake hard or run a stoplight. It might have a great connection with the auto dealership. If you go to buy your car, you notice how they want you to come back for service? I don't know about you, but I'm busy and I often miss my service intervals and you get the occasional phone call from the dealership. Your car's due for an oil change. With an easy connection between the car's position, tracking the number of miles that it's driven, providing regular metadata provided through a connected, location-connected device, you now get an alert on your phone when the car's due for an oil change. Before you come in for service, the dealership has a lot more information about your vehicle, about how it's been driven, if it's been driven hard, if it's ready for its service or not. This allows a better relationship between the company and the driver. So I've just given a whole lot of great use cases, and you might be sitting here overwhelmed thinking, I don't know where to start with all this. Fortunately, there's a handsome man with a nice set of glasses like mine over here named David McCluskey, who's going to come up and talk about how to think about implementing these APIs in your application. David leads our global customer engineering team for Maps here at Google. Thanks, David.
Thanks a lot, Adam. Thanks for that introduction. So as Adam mentioned, my name is Dave McCleskey, and I lead customer engineering for Maps. Adam just talked a lot about some very interesting customer use cases that we are seeing throughout our Google Maps customer base. What I want to do is tell you a little bit about the APIs that are powering some of these experiences and how you can incorporate them in your own solutions to solve some of your own business problems. So what do we offer? So we provide a suite of APIs called the Google Maps APIs. And Google has been investing heavily in building up a consumer mapping platform over the past decade to build the most accurate and comprehensive representation of our world. We have made that platform available to developers with a suite of nearly 20 APIs that allow you access to the underlying location data that powers Google's mapping products. So these APIs are a set of APIs that are scalable. We have millions of developers using them today. They're trusted and comprehensive. And I'll go into a little bit more detail of what these APIs do. But first, I want to show you some stats, because Google loves statistics. Or maybe that's just me. But 2 million websites and apps are using the Google Maps APIs every week. This makes the Google Maps APIs one of the most popular APIs on the internet, right? Google has maps of over 200 countries worldwide, which represents about 40 million miles of mapped roads. And we're providing transit directions daily on the order of 1 billion kilometers a day of transit directions. And that's drawing from Google's real-time traffic data that we now have in over 100 countries. So we have a set of APIs that give access to this information to you for your own applications. And we have APIs for every platform. So whether you're building a web application, iOS application, Android application, or a back-end server application, we have APIs that allow you to bring this data into your own application. So what are some of these APIs? I'm not going to go through all of these. You see we have like 16 APIs here, but I'll go through some of the highlights, and then I'll walk you through some architectures on how you can incorporate them into your own cloud applications as well. But we have the Maps APIs to start with, so our JavaScript API or Street View APIs. These allow you to bring Maps visualizations into your application. But we also have the Places APIs, which give you access to Google's database of over 100 million points of interest globally, and that's business information, business reviews, business photos. We also have an autocomplete service, which gives you that familiar Google type ahead experience for address entry. We have our routing algorithms, our directions API and distance matrix API, which draw upon that real-time traffic information. And I'll walk you through a few of these in more detail. So what do these APIs allow you to do? So first of all, we talked about visualization. Nearly all information in the world today has some sort of geospatial context to it, right? So the ability to display this information on a map allows you to make sense of this information in ways that viewing a tabular set of data doesn't allow you to do. Second is location services. What do I mean by location services? Well, not everything needs a map display. Not everything has a display to begin with, right? So if you're building an IoT device, for example, it just needs to know where it is in the world and make use of that information, right? Make use of that context. So we give you the APIs that allow you to just pull those data feeds without the need of a display. Our APIs give you access to our movement optimization algorithms, right? So our driving directions. We have a distance matrix API, which allows you to calculate actual driving distance and actual driving times using current and historical traffic data. And how this all comes together to give you true location intelligence. So I think where the real power comes in is mixing your own data, your own customer data, your own business data, with Google's data, rich location data, to actually form actionable insights that allow you to make better business decisions. So how does this come together with cloud? So we all know that GCP provides an incredible range of products and infrastructure for storage, and for processing and machine learning too. I think where Google Maps adds value, and the difference here is our set of APIs provide content. It provides content and data enrichment. So when you fuse these two together, you have a backend architecture, you have Google content, merged together in one place with your own content. I'm going to walk you through a few block diagrams which demonstrate how these APIs can be used in a real application with the cloud, and walk through a little bit more in detail some of the use cases that Adam described, how you'd actually go about building something like this. So imagine a fleet tracking application or a connected vehicle type application, right? So you have a vehicle generating a tremendous amount of sensor data, tons of telemetry. You need to stream that to the cloud. So obviously, GCP provides a set of products to ingest that data, things like PubSub and Dataflow that allow you to ingest that data and store that data in the cloud and query that data. But if you want to make some, find some actual insights with that data, you might need to merge it with Google's own location data to add some more value to it. So what does it allow you to do? So we have a set of APIs that will give you road network understanding. For example, our speed limit API to access our speed limit data globally, which would perhaps allow you to audit your fleet of drivers for dangerous driving behavior. We have something called the Snap to Road API. So you're getting GPS positions off these trucks. They're not going to be. There's a lot of noise with GPS measurements. So our Snap to Road API allows you to snap those to the nearest road network and basically use Google's road network to clean up those measurements that you're taking. We talked about the Directions API. We have an elevation API, a global database of elevation data that allow you to figure out the incline, for example, that a vehicle might be going on. And we mentioned the Places API. What Adam mentioned is, if one of your drivers in your fleet is spending a lot of time at a particular location, you might want to know, is it a customer location or is it the local movie theater? So bringing all this data into the cloud with your own data would then allow you to do some very interesting analytics, do machine learning on it, do some visualizations, and make some insights into your customer operations. Similarly, with an Internet of Things use case, this is something we're seeing a lot of excitement around right now. We have all of these new connected devices. Investing in GPS hardware for a low-cost connected device like a wearable might be prohibitive. Our geolocation API is one of our lesser-known APIs, but it's very powerful. We have a global database of millions of Wi-Fi cell towers, which, if you have a device that just has a Wi-Fi antenna, you can query for those nearby Wi-Fi hotspots, use our geolocation API to get a real-time position of that device in the world. Another area that we're seeing a lot of interest around is around Google's capabilities to standardize and validate and verify addresses. So we see this in a number of different industries right now. So for example, you may have used our address autocomplete service, where you start typing an address and Google will provide a list of suggestions. Well, it turns out that if you incorporate that in an e-commerce flow, for example, an online store, using that as part of your checkout process can decrease shopping cart abandonment rate and increase conversion rates by just simplifying that checkout experience, especially on mobile devices where people may not be wanting to sit there and enter multiple address fields. It also decreases shipping errors and delivery errors by having the assurance that the address that's been entered is correct and exists within Google's database. So those are just a few examples of how you can incorporate our APIs in a real-life application. We have a number of plans available that scale with your application. So we have a generous free tier that's suitable for testing and evaluation of our APIs, and then we have premium plans that can have much higher daily limits and will scale with your application and with your needs. It's really easy to get started. If you haven't already used the Maps APIs, just go to developers.google.com/maps. This will allow you access to all of our documentation, how to create a key. And getting started with the APIs is just as easy if you're familiar with the cloud, going into the Cloud Console and activating the APIs right there and creating a key. So I'm going to turn it back over to Adam right now. So I think we talked about some of the tools, some of the stories. I think Adam is going to pull it back together for us with another story on how these components can be used to craft a location strategy for your business.
Thank you, sir. Thanks, David. What I like about what David's presented here is he's showing you the how. We have a lot of documentation online that really allows you to kind of self-serve and get into this in depth. There are Google people around today and throughout the rest of the sessions who can help with the how to implement some of this. But just to put bookends on this session, I started off talking about not so much the how to implement a location strategy, but why we think that big businesses and small businesses and citizens and governments should consider a location strategy to make better decisions. And to tell the story, I'm going to relate another customer engagement we had. Customer engagement sounds cheesy. We got invited to work with a company that is almost the opposite of that small fleet scenario I gave you. I was talking a bit about the company with 2 or 3 florists or maybe half a dozen small taxis or something like that. This is the inverse. We were invited to meet with the CTO of one of the largest trucking companies in the world. And they had an interesting problem, and it wasn't one that you would think off the top was a technology problem related to maps and digital tools. We got invited to tour their warehouse where they service these huge big rigs. We're talking the big transport trailers with very large engines and large loads that they would pull over long haul routes around the world. With so many trucks in their fleet, they had to have a very efficient operations and servicing system. So you can imagine just how efficient it was for them to maintain these trucks. And he pointed in the corner at a pallet, just think a shipping pallet full of boxes. And in the boxes were lots and lots of alternators. And if you don't know what an alternator is, it's like a generator that recharges the battery in an engine. And in a truck, apparently these things are very expensive. And they were running into a challenge. They'd tried a lot of different suppliers, but they were failing. And they were failing prematurely, and they did not know why. It was costing them some money. It wasn't breaking their business, but it was costing them some money. They were having to preemptively replace the alternators in every single one of their trucks as they came in for service. And this was costing them money. They were buying more alternators than they knew they really needed, but they did not know when they were going to fail. They implemented a Google Maps-based asset tracking platform for everything from their dispatch side to getting local information about where a truck was. But one of the byproducts of it was that they were able to get that ping of information from the vehicle every minute or so. And across all the trucks they had hundreds of millions of points per day across their fleet. So they would know at any moment, every minute or so, a lot of information about that vehicle. So from there, they might get the mass airflow sensor, which tells you how hard the driver was pressing on the throttle. They might get the fuel level. They might get the health of certain sensors in the engine. And one of the things they measured was how much power was going across that part that was breaking, how much electricity voltage was going through that alternator. And they started to correlate it in a big data effort, essentially, run on the Google Cloud Platform based on the location data of every single one of these trucks. And they started to see a pattern. They saw that there was a voltage drop in the alternators that failed. And so they said, I can smell something here. There is a smoking gun. There was a voltage drop in the ones that were failing prematurely. But how do we know which ones are going to do this? How do we know when that voltage drop, what's it correlated with? How can we change driver behavior? What can we do? They use the Google Elevation API, a little-known API that Google serves. It has a global picture of the mean sea level at any position or latitude and longitude, the height above mean sea level. So you can actually figure out whether someone's driving over a long route, whether they're generally going up a grade or down a grade. And it turns out the vehicles that spent more than 20% of their route driving up a steep grade were the ones that saw that voltage drop. They were able to identify by doing analytics on the location of their entire fleet and looking at the sensor information and looking at the location, correlating it with context from Google's Elevation API. They were able to preemptively repair and replace those alternators that were the ones that were going to fail. And they cut down in an entire pallet load every month of these alternators that they needed to buy. Now, the reason I'm telling you this story is not because the headline is trucking company saves a couple $100,000 in alternators. That's not the headline. The headline is an alternator parts supply salesperson hangs up her phone and says, you know, I just lost an order. The trucking company doesn't want to buy alternators this month. There are not as many anyway, and I can't figure out why. The reason this is important is that if our premise is right and that the cost of location is opening up new business models, there's an efficiency coming to virtually every business, not just rideshare apps, not just vacation rental apps, not just your coffee ordering app, but to every brick and mortar business and traditional old businesses. Location is starting to force efficiency. This change will force all sorts of businesses to have to include location in their strategy. So the question we like to leave people with after telling stories like this and providing some tools, as David has done in the how-to, is maybe when you get back to the office and you're talking a little bit about what you learned at Google Next, ask some of the people that you work with how they see location and how it works in your world. You know your business and your industry and the reality of it far better than Google ever would. But how can location help you craft a strategy to get out in front of some of these big changes that are coming, thanks to optimizing our business using location? Thanks everybody for sticking around. Thank you.